We're going to be cracking open Basic Mechanics Applied to Orthodontics by Dr. Jean-Marc Retreve and Dr. Catherine Cousset.
Awesome.
And we're going to, see what we can find out.
Sounds good. I feel like it's so cool how much physics is involved.
I know, right?
We always think of orthodontics as just aesthetics, but it's like at its core, it's really harnessing these like fundamental forces to move teeth.
I know. It's like, remember those physics laws you learned back in high school?
Right.
Well, they're alive and well. They're moving your teeth.
Yeah. So, I mean, like, think about it.
Yeah.
Your teeth are just like hanging out, minding their own business, and then braces come along.
Right.
And they apply a force to, like, change their position.
Totally.
So that's where Newton's first law comes into play, inertia.
So it's not just about pushing and pulling.
Right.
There's this whole concept of inertia that has to be overcome.
Absolutely. Like, it's like if you try to push a really heavy object, it takes way more force to, like, get it moving than to, like, keep it rolling. Teeth are kind of similar. They, like, resist that initial change.
Okay.
And that brings us to Newton's second law, acceleration.
Okay, so the heavier the object, the more force needed to move it.
Exactly.
So does that mean stronger forces mean, like, faster tooth movement?
It does, precisely.
Right.
The force applied to a tooth is directly proportional to its acceleration.
Wow.
But it's not just about, like, speed, right? The direction of that force is, like, super important, too.
Oh,
so orthodontists, they have to, like, carefully calculate the magnitude and direction of that force to get, like, the exact movement they want.
Right.
Whether it's, like, moving a tooth forward or backward or even rotating it.
There's a lot of precision involved.
Yeah, for sure.
It's not just slapping on some braces and hoping for the best.
Right.
I mean, but
it's like a science.
One thing I'm still wondering about is, like, when we talk about a force being applied to a tooth, where exactly is that force being applied?
That is a great question, and that's where the concept of the center of resistance comes in.